Can you guys hear me? Yes, okay. So here it's a vertical stretch or shrink. By a factor of, okay, so we're going to graphing use f of x equals ax squared. And A is going to determine if it's a vertical stretch or a shrink by a factor of A of the graph, y equals f of x. So I'm going to highlight A. So that's our leading coefficient, okay? Okay, so if A is greater than 1, then this is called a vertical stretch. It's like thinking of, any number that's bigger, that's how many times bigger it's getting, so you're stretching it. So an example of what that would look like would be if you get an equation that says g of x equals 3x squared, then you automatically should think, okay, because the leading coefficient is bigger than 1, this is a vertical stretch, okay? Now, if A was between 0 and 1, for example, like a fraction, then this would be called a vertical shrink. So the way that looks is if you have a coordinate plane, and your parent function is this is your parabola. This is y equals f of x, where a equals 1. Then your vertical, let's say your vertical stretch, if you're stretching it, it would make the parabola do this. This would be an example of a stretch. And then if you have a shrink, you would have something like this. Okay? So this would be a vertical shrink. And the one in pink would be a vertical stretch. Okay. Then sometimes you could have, this is another example, so I'm going to put a star. You could have y equals negative f of x. And it doesn't matter what a is, but if you have a negative right here, then this is called a reflection in the x-axis of the graph of y equals f of x. Now, you would have, if right here in the front, if A is less than -1, then you're going to have a vertical stretch. An example of that would be if you have an equation that says f of x equals -3x squared. Then you could also have the coefficient a could be between -1 and 0. So that would be like a negative fraction, right? And that would be called a vertical shrink. And so let me show you how both of those look. Okay, so here you have your parent function, the parabola, but this is a -a. So here we're going to say a equals -1. Your vertical stretch, this is the one I'm going to make pink. Your vertical stretch would be narrower and it would be facing downwards if it's a negative and if it's if a is, less than -1. Okay. And then you would have a vertical shrink if a was a negative and it's a fraction. Okay, so right here in green, this is the vertical shrink. And in pink, that's your vertical stretch, okay? Okay, let's move on to the next part. If you have your calculators with you, this is the part that you want to use it for. So if you need to go get it, go ahead and do that now. Grab your calculators. Okay, so graphing y equals ax squared when a is greater than 0. Give me 1 second. Okay, so let's say, for example, I'm going to call this example 2. The directions say graph g of x equals 2x squared. Okay, so from what we just wrote, we can see that a is a positive and it's bigger than 1. Okay? Then it says compare the graph to the graph f of x equals x squared. So this is the parent function. They want us to compare g of x to the parent function. Okay. So the first thing is when you're using the calculator and you want to compare, get your graphing calculator and we're going to graph the 2x squared. Okay. Now, you could graph the parent function. That way you can compare the two. So in your calculator, you're going to go to New Document. And we're going to go to Add Graphs. Right here. Okay, so let's put the parent function. Just put x to the second power. Push Enter. And you're going to get the parent function, which is a regular parabola facing upwards. Okay. Now, to graph the second equation, we're going to press Tab. And then notice how it says f2 of x. That means that's the second equation you can graph. So now we're going to put 2x squared. Okay, push Enter. And what do you notice happened to the parabola? Yep, it got narrower. Okay, so that's what we said in the notes, right? That it's going to be narrower and it's facing upwards. So that's how you compare it. When you have to compare, you got to talk about what happened. Okay, so we're going to say as the answer, both graphs have the same vertex. And can you guys tell me what is the vertex for both of them? What is it? You're right. It's 0 and 0. Okay. So remember, you're saying it as a location, right? The x and the y. So it's 0 and 0. We said that both are facing upwards, right? They're both facing upwards. So that's the next thing we're going to put. Both, we can write open up. What about the axis of symmetry? What do you think is the axis of symmetry for both of them or for one of them? Do you remember the axis of symmetry? So what is it? If you cut this parabola in half and you draw that dotted line, where does it go through? X equals what? Yep, x equals 0. So we're going to say axis of symmetry. I'm going to put AOS as short, right? This is axis of symmetry. And I'm going to write it one time. That way we know. That means axis of symmetry. So the axis of symmetry is the same, which is x equals 0. Okay. I think it froze, so I'm going to wait for a little bit. There we go. Okay. So axis of symmetry is the same, x equals 0. And then you guys told me that the new graph, the graph of G, is narrower. So that's what we're going to write here. The graph of G, the graph G is narrower and then we're going to say why it's narrower. So we're going to say the graph of G is narrower because it's a vertical stretch and then we're going to say by a factor of 2. Okay, so here's what's important. We said they have the same vertex. They both open up. The axis of symmetry is the same. The graph G is narrower by a vertical stretch by a factor of 2. That's how we compared. So there were several things that we compared. We compared the vertex. Is it upwards or downwards? The axis of symmetry. Is it wider or narrower? Is it a vertical stretch or a vertical shrink? And by how much? Okay, so that's how we compare. Now, before we use the graphing calculators, I used to have my students actually graph this. So I'm going to show you what we've done in the past. In the past, we would write the directions, and then step 1 was we would make a table. So this would be the table of your new graph, and this is the table of the parent function. Now, the parent function will always be the same table. This is like the parent function will always be this. But your new graph, your new equation would depend on what's here, right? So if I plug in a 0 into 2x squared, what's your output? And then you would write your output. So we would actually make the table, and then once we have the table done, we would plot the points on paper. And so here's my parent function, and then the blue is the new graph. And then step 3 would be draw a smooth curve through the points. But since we have the graphing calculator, we don't have to do it on paper, okay? Yay. Okay, let's move on to a different example. Okay, so the next part is going to be graphing y equals ax squared when a is less than 0. So right above it, we graphed it when a was greater than 0. Now we're going to do when that's less than 0. Okay, so this is example 3. The directions say graph h of x equals negative 1/3 x squared. Compare the graph to f of x equals x squared. Okay, well, let's use the calculator to see how it changes, okay? Okay, so we're going to go ahead and go back and start over in the calculator. And now it's got my old information, right? So I'm going to just go home, click on home. And we're going to go to new document again. And do you want to save? No. And now go to add graphs. Okay, so here we're going to put the parent function, right? They want us to compare it to the parent function. So we're going to put x squared. Push enter. And there's our parent function. Now we're going to put the second equation. So I'm going to press tab. And then it says f2 of x. That's the second equation. So now we're going to put negative 1/3 x squared. Push enter. Okay, so the graph of h opens downwards and it's wider because it is a vertical shrink by a factor of 1/3. And then the other thing you have to mention is, remember this negative right here in the front? Not only did it open downwards, but you have to explain why did it open downwards, and we're going to say it is a reflection in the x-axis.